Last week's video ended with a bit of discussion on different options for this block, given the parent bores of the block being out of round and the provided finished sleeves having a pretty poor surface finish. In this week's video, we're going to discuss the fix for that our customer opted for, but to start out, our other machine is free, so we're going to install a few key locking thread inserts in the head bolt holes that we weren't able to do last week. The threads in 3 head bolt holes are stripped, so with the block set up on the table of our Peterson TCM25, we're going to level up to do some machining. A machinist level is used, and the table can be tilted to get the deck perfectly perpendicular to the spindle of the machine. I went ahead and grabbed the right drill bit to fit in our 7/16 inch head bolt holes, and with it chucked in the machine, we can use the air float table to center up on the head bolt hole as the bottom of the hole is still intact. After getting the block positioned on center, we'll switch over to a larger drill bit to drill the hole to be tapped with 9/16-12 threads to match the outer threads of the key locking insert. With the threads tapped, we can use the provided tool to screw in the insert, at which point we use another tool to hammer the locking pins into place. In the past, I've had questions about different thread inserts, but I think different inserts have their place. While I do believe a helicoil would be acceptable in this instance, if installed properly, a solid style key locking insert like this just provides that extra peace of mind. The process was repeated on the other 2 stripped holes before we went ahead and moved over to installing the sleeves. Although we would prefer to have gone with an oversized OD sleeve, the price difference didn't seem to make it worth it, but the customer did opt to provide us with a set of 20 thousandths oversized pistons, which will at least allow us to finish the sleeves to the proper clearance and have them come out round and straight. After having cleaned the block a little bit better, we can see that the bores aren't perfect, but they aren't in bad enough condition to justify any further work before installing the sleeves. After measuring the sleeves and the bores, we should have on average around 1,000th press fit, but again I say average because the bores are a little bit egg-shaped and not straight. Just to be safe, we're installing the sleeves with a small band of Loctite retaining compound on the bores. For the new viewers, yes, we know you can use liquid nitrogen to shrink the sleeves and install them, as we've done in different videos in the past, but there's also nothing wrong with just pressing them into place in the shop press like we're doing here. Both methods work, and both have advantages and disadvantages, but at the end of the day, the end result is the same. As you may recall in the last video, we did deck the block and recut the counterbores, and the specification for sleeve protrusion on this engine is from flush to 3 thousandths above, and on most of these sleeves we came in just about 1,000th protrusion, which we're happy with. Sometimes we do aim for that higher side of spec, but with the way that the head gasket barely overlaps one section of the sleeve on these, we didn't want a huge step to be trying to seal over. As we stated in the previous video, when you press a round sleeve into an egg-shaped bore, you also end up with the ID of that sleeve turning into an egg shape, which is why we prefer semi-finished sleeves when doing this type of work over the finished sleeves like we have here. They pretty much always need to be touched up after being pressed into place. Our fix in this case is rather than running the standard size pistons that were provided in the sleeve assemblies, the customer is sending us 20 thousandths oversized pistons, allowing us to rebore the ID of the sleeves and achieve a finished cylinder that is round, straight, and on size. As such, we've set up a cutter and will center up to bore each cylinder, leaving a few thousandths to finish it out to the nominal size in the cylinder hone.
Originally, when we started on this job for the customer, it was supposed to be just a rebuild the head. But he brought the head in and we realized that the head was cracked, so he's since replaced the head with another one. But I'm assuming this is probably the cylinder where it was cracked, and it probably had gotten a little bit of water into the cylinder, and then when they tried to start the engine, everybody knows that liquids won't compress, so when it tried to compress that and it couldn't, it put a kink in the connecting rod here. About the time we think we've got figured out what we need here, why we move on a little bit further and then you find just one more thing that's wrong, and you move on a little farther and you find one more thing that's wrong, and it just seems like it'll never end.
As you can see, our cutter is leaving us just around 3 thousandths to finish in the hone, which is a good spot to be, so we went ahead and got all 4 cylinders bored before moving the block over into the Sunnin CV616 cylinder hone. We'll set up the stones in the hone head, adjust the stroke length of the machine, adjust the block height for the proper overstroke, and make sure that the belts are in the correct position for the spindle speed and stroking speed. The new pistons are hopefully going to arrive on Monday, so today we're basically roughing out the bores to get them close to our nominal bore size, and once the pistons arrive, we'll be able to double check the measurements and quickly finish out the cylinders for the proper piston to wall clearance. As we hone the cylinders, we take our time and stop once in a while to measure with the bore gauge and ensure that we're keeping the cylinders straight from top to bottom. If we see a tight spot in the cylinder, we can pull the dwell lever to dwell the hone head at that position in the bore, which takes out more material and therefore straightens out the tight spot. It's not a perfect indicator, but when the needle on the load meter of the machine isn't bouncing heavily back and forth, it's an indication of a straight cylinder. This isn't the fully finished product, but I guarantee that the surface finish here would run better and longer than what was in the supposedly finished sleeves that came in the kit. We can also run a bore gauge from top to bottom at different points in the cylinder, and we can see that we are much straighter and definitely much more round than the sleeves were just after being pressed into place. At this point, we'll wait for our pistons to arrive to fully finish it out. You all killed it on the last video, and we had tons of comments asking for a quick part 2, so hopefully this quick little video satisfied your curiosity on the fix. Thanks for watching, and we'll see you in the next one.